Students, you are in floor one. Therefore, you are supposed to read one communication subject, and that communication subject is said to be optical fiber communication system. Uh, Therefore, to some extent, you could have got some idea on onto this optical fiber communication. So you could have got this in your engineering first year. Else, you could have got this in your cluster also. To some extent, you just have got some brief idea onto this optical fiber communication system. And we know that in this optical fiber communication system, we just use one basic guided communication channel, and that communication channel is said to be optical fiber cable. And I know that many of you people are aware of this optical fiber cable, and you know that in this optical fiber cable we just have got two types or two members, you can say. One is said to be core, other one is said to be recording. And hope I guess that you know the purpose of using two different materials into this optical fiber cable. So if not, I just give you the explanation of using those two different materials into this optical fiber cable. As this is the first class, therefore I don't want to discuss more regarding this optical fiber cable, but instead I just want to discuss some brief points which I think are very important to this optical fiber communication system. So before going to brief out all those important points, so let me discuss the books which are very much helpful in referring the concepts of this optical fiber communication. Therefore, here I just have given three books which are even prescribed in your syllabus copy as well. So the first book is said to be Optical Fiber Communication by Kaiser. Second book is Optical Fiber Communication Principles and Practice by John M. Senior. And the last book is said to be Fiber Optic Communications Technology by Jeffrey K. Manby. So this third book is not either a textbook or a reference book in your syllabus copy, but this is said to be the best book for this optical fiber communication. Concept is that concept is very much clear in the case of Jeffrey K. Manby textbook. So if you want, you can refer that Kaiser and the senior textbook also. So those books are also better, but the simpler concept is available in the Jeffrey K. Manby textbook. Therefore, you just take whatever textbook you want, either from your central library, or you just purchase it in the bookshops. So these are said to be some points that I just want to discuss in this first class. So you should know why this optical fiber communication should be used. In what way this optical fiber communication is more advantageous when compared to other communication systems. So the first point is that the first point is said to be the bandwidth that this optical fiber cable is going to provide. So this bandwidth of this optical fiber cable is very high when compared to other communication channels. Why this bandwidth is high? Because we just choose the frequency of this optical fiber cables from the top three region of EM spectrum, I can say. So I have to take one diagram for this electromagnetic spectrum, and there I should explain the bandwidth you can say, or frequency range you can say. Probably in the case of optical fiber communications, we just don't use the word called as frequency, but instead of using the frequency word, we just use this word called as wavelength. And we know that between these two parameters some relation has been existing, and that relation is said to be lambda is equals to c by f. Therefore, it is clear that this wavelength and frequency, both of these are inversely proportional. So either you can express this bandwidth of any of the communication channel in the frequency, else you can also express that in terms of wavelength. But in the case of optical fiber cables, we just prefer this wavelength over this frequency. So first point I just have written is regarding the bandwidth that these optical fiber cables are being providing. So I said that these optical fiber cables are going to provide the bandwidth, and that bandwidth will be in the powers of tens, I can say. So the bandwidth is so that bandwidth is said to be 3 into 10 power 13 hertz to 3 into 10 power 15 hertz. So in some books it is being given as 10 power 11 hertz to 10 power 13 hertz also. So you remember that the bandwidth of this optical fiber cable will always be expressed in the powers of tens only. So because of this high bandwidth, the channel capacity of this optical fiber cable is very high. So I just have said this because of a law, and that law is said to be Shannon-Hartley law. So here I just have used one law here. So that law is equals to, I mean, that law is C is equals to B into log 1 plus signal to the noise ratio to the base 2. So signal to the noise ratio concept I'm not discussing, but I just want to say that this C and B, so both of these are directly proportional. So this C is there, so this C is said to be channel capacity, and this B is said to be the channel bandwidth. Therefore, this bandwidth will be expressed in terms of hertz, whereas this channel capacity will be expressed in terms of bits per second. So if you increase this bandwidth, then automatically the same impact will be onto the channel capacity. And so based on this Shannon-Hartley law only, we just have said that higher bandwidth directly implicates a higher channel capacity to these optical fiber cables. Whether you believe this or not, so because of this higher bandwidth only, it is possible to transmit a total of 3 lakh unidirectional voice signals, or we can also transmit a total of 90,000 video signals into that minute optical fiber cable whose diameter is less than the diameter of the human hair. So this is said to be the biggest advantage that this optical fiber cables in optical fiber communication system is providing. And similarly, the second advantage is said to be, so whenever we launch signals into this optical fiber cables, then those signals are more secure. What I mean to say is those signals are not going to interfere with the signals that have been existing into the same optical fiber cable. So these signals are electrically isolated. So why this electrical isolation is been existing with this optical fiber cable means, so this optical fiber cables are being designed, or those are being fabricated using silica or sand as the material, and we know that this silica is not a good conductor of electricity. Therefore, with some dopants, you can either increase the conductivity, else you can also decrease the conductivity. So if you take raw silica, so then in that case we could say that those are not good conductors of electricity. So that is the reason of saying that the signals which are being propagating into the optical fiber cable are electrically isolated. So this is the second point of saying that these optical fiber cables should be used. And similarly, third point is, so the third point is regarding the strength that these optical fiber cables are having when compared to other other guided communication channels. So these optical fiber cables are more stronger when compared to other communication channels. What is the reason of saying these optical fiber cables are more stronger? Means these optical fiber cables are being designed with one material, and that material here is said to be Kevlar. So this Kevlar is said to be one material that is being used in order to design these optical fiber cables. And even in the standard earphones, the same material will be used for its designing. So if you take the earphones designed by Philips or Sony, then you could find this as the strength member there. Mm, this is said to be the third point of using this optical fiber communication system. So this is said to be the brief points that I have mentioned for saying that these optical fiber cables uh, in the optical fiber communications should be used. And similarly, uh, the second point is regarding the evolution of the optical fiber cables that I just want to discuss in this first class. So how these optical fiber cables were evolved, and before optical fiber cables, what was the communication channel that is available. So these optical fiber cables were, were invented in the year 1950s or 1960s. These optical fiber cables were being invented. However, those optical fiber cables are not being used during then. So the reason of not using those optical fiber cables is its higher attenuation. Attenuation provided by those optical fiber cables is greater than 10 decibels per kilometer. dB per kilometer is said to be the uh, attenuation of these optical fiber cables. So what figure I said? I said the figure has 10 decibels per kilometer. That is said to be the attenuation that these optical fiber cables uh, during then uh, have provided. And therefore, because of this higher attenuation, optical fiber cables are not being used, but those have been kept aside. Instead of using these optical fiber cables, coaxial cables are being used during then. And within 10 decades, these optical fiber cables have been designed in such a way that its attenuation has drastically dropped down from 10 decibels per kilometer to less than 1 decibels per kilometer. So this attenuation is there. This attenuation is the frequent function of the wavelength. As the wavelength changes, attenuation is there. So that attenuation is going to change. So this attenuation concept will come in unit 2. Therefore, during then we just discuss this attenuation well in that year 2. Therefore, so you just remember that within 10 decades, optical fiber cables have been developed in such a way that its attenuation has got reduced, and that value has come down to less than 1 decibels per kilometer. And the third point that I want to discuss is how message will be sent in this optical fiber cables. So message is there that message will be sent by varying the intensity of these light pulses. Therefore, it is clear that the message is that this message will be conveyed through through these light pulses only. So we need to vary the intensity of these light pulses, and accordingly, this message will be sent towards this receiving end. So it means that in the case of optical fiber communication as well, we just do some modulation, and that modulation is said to be intensity modulation. So we need to vary the intensity of these light pulses according to the message signal or modulating signal, I can say. So some equation is there. So that equation is P of omega is equals to P naught into 1 plus omega tau I square or power 1 by 2. Even this equation 2 will come in unit 3. So for typing, you just remember that this message will be sent by varying light pulses in the optical fiber cable. And similarly, light is there. This light is going to propagate through this optical fiber cable by undergoing several multiple total internal reflections. So this point is again something important, I can say. And so this light, we just have launched one light pulse into optical fiber cable, and this light pulse should be delivered at the receiving end, and this light has to propagate through this optical fiber cable. Therefore, the propagation of this uh, light pulse will be by undergoing several multiple total internal reflections. And so it means that we need to launch this light pulse into the optical fiber cable. Therefore, to launch this light pulse into the optical fiber cable, we either has to use light emitting diode as the optical source, else we could also use one more optical source, and that optical source is said to be laser. And so not only these two, but we just have got many number of photo sources or optical sources that are available in the physics. But here we just have to use LED and laser because these have got some requirements, and LED and laser are going to satisfy those requirements. Even we have to discuss these requirements in unit 4. So in the unit 4, we have to discuss this optical sources. So for time being, you just remember that to launch this light into the optical fiber cable, either we have to use LED, which has got no amplification, and if not LED, we have to use laser, which has got amplification. So if at all you are using LED as the optical source, then in that case we need to use pin as the optical detector. So here we have launched this optical pulse into the optical fiber cable. Therefore, we need to get the same message back from this light pulse which has been launched into the optical fiber cable. Therefore, to do that recovery, again we have to use either pin or APD as the optical detector. Therefore, it is clear that this LED or laser and pin or APD, so both of these are said to be the transducers or converters, I can say. So uh, one is converting electrical signal into the optical signal. The other one is converting optical signal back into electrical signal. Again, these optical detectors we need to discuss in the same unit 4 itself. And after that, I just want to discuss the two materials that have been existing in this optical fiber cable. Already I said that in this optical fiber cable, we just have got two materials. One is said to be core, other one is said to be cladding. So we know that any of the material has got the refractive index. So here core is there and cladding is there. Both of these are different materials. Therefore, the material, I mean, refractive indices of both of these materials is different, I can say. So core, I just have assumed the refractive index as N1, whereas for the cladding, the refractive index is been assumed as N2. So interesting point is the refractive indices of both of these is not same. So always core refractive index is high when compared to cladding refractive index. Why this should exist between this N1 and N2. So why always core refractive index should be high when compared to cladding refractive index? What happens if core refractive index is less than the cladding refractive index? So you just remember one point regarding these light pulses. And so always these light pulses will propagate into that material whose refractive index is high when compared to other material. So if you think that the core refractive index is less than the cladding refractive index, then in that case propagation of light is not possible. So always you remember that core refractive index is high when compared to cladding refractive index, then only this light ray is there or light pulse is there. This light pulse is going to propagate all through the length of the optical fiber cable. Mm, So that is the reason of choosing N1 higher than N2. And after that, I just want to discuss this modes and configurations of this optical fiber cable briefly. So probably you could have got some idea onto the modes, and similarly you could have got some idea onto the configurations of this optical fiber cable. So what do you mean by a mode? So mode refers to the path that this light ray in the optical fiber cable is going to take. So it means that to this light ray, this optical fiber cable is providing many number of paths. So static is starting from the path which has been existing onto the fiber axis, and that path which has been existing away from the fiber axis. So again, we have to discuss this in unit 2. I think modes and configurations topic is there. So during then we just discuss this modes and configurations topic. So for time being, you just remember that to this light ray, optical fiber cable is going to provide various paths, and each of the path here is being referred as a mode here. And similarly, so modes, after the discussion of modes, we just move on to the configurations. And so in this optical fiber cable, we just have got three configurations, and those configurations are said to be SMSI, MMSI, and MMGI. So remember that uh, multi-mode step index fiber, I mean MMSI stands for multi-mode step index, SMSI stands for single mode step index, and last one is said to be multi-mode graded index fibers. So you just remember that single mode gradient index fibers is not available. So it is impractical to design this single mode gradient index fibers here. So probably we just have got two types of optical fiber cables, and those are said to be step and graded fibers. And from that only, we just go for designing the single mode optical single mode step index, multi-mode step index, and multi-mode gradient index fibers here. So all these are different in terms of the refractive index profiles as well as the profile parameter. So if you take this MMGI, in the case of MMGI, we just define a parameter, and that is a total profile parameter indicated with alpha. Whereas in the case of step index fibers, we don't define this profile parameter. So this is what the topic that we have to discuss in Unit 2. And after that, in the same Unit 2, we're going to discuss the various losses that this optical fiber cable is going to incur, and along with that we have to discuss the concept of widening of the pulse, or that widening of the pulse can also be called as pulse broadening, and simply this pulse broadening or pulse widening is called as a dispersion here. So we have to discuss various losses, and those various losses are called as transmission losses. So we have to discuss this absorption loss, we have to discuss bending loss, we have to discuss when we discuss this core and cladding loss also. All these losses we have to discuss in unit 2, and along with that we have to discuss widening of the pulse, and that widening of the pulse is said to be dispersion. So again, in the dispersion we have to discuss intermodal dispersion and intramodal dispersion. Intramodal dispersion is called as chromatic dispersion. This chromatic dispersion is very significant in the case of uh, single mode fibers, and in the case of multi-mode fibers, this intermodal dispersion is very much significant. So all these are said to be the brief points that I just want to discuss in this first class, as this class is the first class. Therefore, in the next coming class, I just move on to the first topic in this unit 1. I'm just finding this session.